All right, let the grading begin. So, you have to state negation, and notice that I didn't even ask you if the original statement is true or false. However, on the real test, you are going to have to say true or false. These are like just too easy. So there exists a real number x such that for all real numbers y, comma, x plus y is not equal to 0. Very good, correct. So that's minus 0. Now, when I give you a test, you're going to have 8 problems. The most they pick up is 8 points. So the most you can lose is 64. So where does the other 36 points come in?
Name.
Yeah, it's free. So even though you get, if you get everything wrong, you get 36.
Alright.
That's what you want. Is that going to help your average 36?
Yeah, it does.
Well, more than 0.
Okay, B. All triangles are not equilateral. Very good. Minus 0.
Can we say scaly?
That's
No, what about like isosceles?
Alright.
No, not equilateral. Not equilateral. C. C, that's what C. When you make up your own, then trouble occurs. X is less than 2 or X is greater than 5. Good. Some perfect numbers are not even. Good. Could you have said odd instead of not even?
No.
Yes. Because when you talk about perfect numbers, they're already whole numbers already, so you don't have to worry about fractions and stuff like that. E, x is greater than or equal to 3, and x is not equal to 7. What is this true? I didn't ask for it. How can...
You're welcome.
That's a no.
No.
Take off it.
Whoa.
I didn't ask for true or
Yeah,
false.
but when I asked you, when you gave the homework, you're like, yeah, but you're gonna have to, and I'm like,
But
okay.
that's
so-
how can you tell if the statement's either true or false?
Because
It doesn't even make sense. I should
because
take
it
out
could
more.
be true.
And there we go. F. Here we go. Fatal error. This is it right here. Minus 4.
Who's that?
Look. If you have if, box,
It's a and.
then triangle, the negation is box and not triangle. This is important now. The negation of a conditional statement is an and statement. It's box and not triangle. So what should it be? It should be
X
x box and not triangle. X squared is less than or equal to 4. That's what the answer should be. See, that would be a fatal error. The negation of a conditional statement is not another conditional statement. It's an and statement. Okay, number 2. State the converse of the contrapositive, which is the inverse. So Q implies not P. Very good. Minus 0. B. If Q implies P is false, state the truth value of that. Okay, I don't even know, so let's do it. Not Q implies P. Now, when is the only time a conditional statement is false?
True, false.
When the first one is true and the second one is false. Did you guys get that?
Yeah.
Or is it 50-50 chance? Okay, so what are we trying to find? State the truth value of P if and only if Q. Well, if not Q is true, what is Q? False. And P is false. And if you have two false statements with the biconditional,
True.
it's true. So when they're both the same, it's true. Very good, that's correct.
Minus 6.
Why would that be minus 6? It's correct.
Wait, 2P.
See, the key there is right here. If you have a conditional statement that's false, that means the first one is true and the second one is false. That's the only time it's false. Okay, number 3. Prove by constructing a truth table that P and Q implies R is logically equivalent to P in Q. P implies Q implies R. So we made the truth table. Oh, you didn't even put the training wheels.
He's a beast.
Do you put them on the test?
No, you're going to. Okay, here are the training wheels. So P and Q would be true, true, false, 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 false. Very good. Implies R. Okay, you just tell me, is this correct?
Yes.
And is that correct?
Yes.
Okay, so minus 0.
True, false, wrong.
Okay, number 4. Construct the truth table whether this statement is a tautology. What is a tautology again? All true, contradiction, or neither. So you do it, it's all false, contradiction. Everybody got that? Good, minus 0. 5a, show that the following argument is valid by showing the conclusion is true. Okay, did everybody, you're supposed to have a double line there,
Oh.
minus 1. Or should I make it -1 for each centimeter?
Make it really small then.
Okay, so in the first premise, is this the one you're looking at? Iwakiri? I don't want to mention names.
Yeah.
Oh, wait a minute, you gotta move the thing. The camera. Whoa! Iwakiri, remind me to move the camera
Okay.
back to the original spot. Okay, there. Okay, so which one represents the first sentence? Is it this one right here, I'm assuming?
Yeah.
Okay, and then for this one, oh, what the heck is this? It's like not even the same length.
I screwed up.
And then this one is, okay, so did everybody get the correct things? True, 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 false, true, 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 true. Everybody got that?
Yes.
Yeah.
Okay, and then in this, did everybody get true, false, true, 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 false, true, true?
Yes.
And then in this one, true, false, true, false, true, 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 true.
Yeah.
Okay, so what lines in the truth table are you supposed to look at whenever the premises are true? So here are the two premises. When are they both true? In line 1, in line 3. 3, 4, 5. In line 5. See, but you didn't line it up, so it's kind of hard to tell. Line 5. Line 7. And line 8. So you're supposed to be indicating that you're looking at lines 1, 3, 5, 7, and 8. Did everybody do that? You
No,
indicated?
Wait, why
No.
1, 3, 5?
Because both of the premises are true. See, both true. Now this one, they're not both true, so you don't look at that.
Oh.
Both true, both
I
true.
was,
Can you
What?
write the numbers down of the lines?
No, just circle, good enough. And then in each of these cases, does the conclusion also come out true? Height, 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 height. Then you can say it's valid. So how can you say it's valid then if you didn't do that? So I gotta take off additional points. So besides the double bar, I give you some credit, -6.
What?
Hey, just don't make the same mistake.
Wait, what was the -6 for?
Because you didn't indicate, okay, you indicated lines 1 and 3, but you didn't indicate lines 5, 7, and 8. Plus, you didn't put the double bar, and then, how can you say it's valid when you're not even looking at the proper lines? There you go.
Oh my god.
Oh,
yeah,
yeah,
one more for fun. Okay.
Oh.
We're back.
Turbo.
Dude, don't worry, mine is
No, see, because when you're proving an argument is valid by using the truth table, you have the two premises, double bar, conclusion.
I think I like the easier proof of this.
Actually, you don't have to.
I'll redeem
I
myself.
felt like taking off one.
It's probably
But isn't that the way I did it the first time? Yeah. Okay, 5. That's okay. You get the minus points now. Just make sure you don't get the minus points on the test. You learn.
Oh.
Okay, what is 5b? Showing that the conjunction of the premises, so here are the two premises. The conjunction of these two is an and statement, implies the conclusion is a tautology. So what you're supposed to do is work it out and it comes out all true, therefore it's a valid argument. That's the second method. So this one is a -8. Even though I don't think there's enough work here. Oh, so you were using the results from this one then, Kojima?
Yeah, sure.
Just say it, just say yes.
Yeah.
Yeah, okay, then good. Okay, so let's total up the damage.
-0. Oh my
-6,
god.
-4, -2. So what is this? Period 5 got minus, what?
Just put minus like here.
Minus 0,
The 2
12.
doesn't count though.
12. So, but then, still got some more to go, right? We're not done yet.
Oh.
But I'm just gonna do it on the board.
That's what, 88%?
Well, that's if everything else is correct. I'm pretty sure that last problem, some of you didn't get it correct. I would bet,
7's money.
What?
I would bet all the money in my wallet.
Easy though.
Yeah, I didn't get that one.
That's what I thought.
If and only
Just
PQ.
just make it look like that.
Okay, so the rest of it, to save time, I will do it for you. Now remember, an indirect proof,
Yeah, but how would you represent that? In gates.
You just
not.
Hey, who knows? Maybe period 6 could be minus 27 or something.
Hey,
I don't
they're
know.
gonna be minus 13.
Or maybe it could be minus 4.
Minus 0.
Minus 13, minus 64.
Oh, dude.
All right, now we gotta do 5. What are we doing?
5C.
5C. Okay, I gotta read this thing. If Argentina joins the alliance, then either Brazil or Chile will boycott. If Brazil joins, then Chile will boycott. No, Brazil boycotts. Therefore, if Argentina joins, then Chile will boycott. Okay, did you guys write that?
Yeah.
Well, you have to use that for all 3 problems. Now, we're doing an indirect proof. So what's the first sentence?
Suppose.
Suppose. So again, what is a valid argument? When this is true and this is true, this will be true. But we're going to suppose that this is false. A implies C is false. Now, if you don't write down that first sentence, probably it's a fatal error. Really. Now, what can we conclude if you have a conditional statement that's false?
A is
A is
true.
The
false.
first one is true and the second one is false. So then, A is true and C is false. Because if you don't have that, how can you take it back up here and get contradictions? You have to make that conclusion there. Okay, and then, okay, where do you want to do? You want to take it to the first premise or the second premise?
Second.
2, yeah, 2.
Okay, the second. Now, here's a conditional statement that's true. We just figured out C is false. Then therefore B has to be
True.
no.
False.
No. If B is true, look, if you have a conditional statement, if the first one is true and the second one is false, it makes it false. But we know it's true. That's what a premise is. A premise is a true statement. So B must be false. So B must be false in premise 2. You guys understand? These 2 statements are true. Okay, now we take that back into the first premise now. Thus, I like thus better. Thus,
I like this.
so,
Therefore,
so what do we know? What do we know? B is false, C is false. So if you have
must
2
be
false
false.
statements with an or, what is that?
False.
So this whole thing is false. And if you have a conditional statement that's true, but the second part is false, the first part must be.
False.
Who said true again? That's the same thing. You cannot look. If you have a conditional statement, if the first one is true and the second one is false, it's false. But it's true, so A has to be false. Thus, A must be false in premise number 1. Does anybody see a contradiction?
A.
A.
Yes. So, contradiction,
Exclamation point.
exclamation point, A cannot be both true and false. Because look right here, A must be false, but over here it says A is true. No can. That's the contradiction. Therefore,
The argument.
the argument is valid. Woo! Now, like I promised you, you don't have to write out the whole thing. All you gotta do is fill in the truths and the falses. So, like before, I used to make them do like actual statements, but I'm gonna go easy on you. So, it's gonna look like this. Suppose A implies C is blank. Then A is blank and C is blank. So B must be blank. Thus, A must be blank in premise number 1. Contradiction. A cannot be blank, blank, and blank. Therefore, the argument is valid. All you gotta do is fill in the truths and the falses. Can do.
yeah. For this one, could we have used C as
1 out of 30.
a contradiction because it,
No.
Oh.
No. No, because over here it says C is false.
1 out of
No,
100.
C is false, but there's no contradiction that says C is true here.
okay.
A contradiction means a statement is both true and false. Okay.
Okay.
Anyway, you don't have to worry because you just have. So even if you don't know anything, look, how many lines do you have to fill in? 1, 2, 3, 4, 5. Come on, does this not even count? Okay, 6 and 7. So even if you just randomly guess at each one, the probability is 1 out of 128 that you're gonna get it correct.
Higher than 45%.
I think the one you're gonna get on test will be a little more involved though. This is kind of a little bit simple for you, yeah?
No.
Come on, not PCH! The H stands for something, you know,
Or
not help. Okay, let's do number 6. Number 6. Okay, so the first thing you gotta do is you gotta symbolize. Now, if you symbolize one of them wrong, then that's pretty much a fatal error because there's no way you can get a conclusion otherwise. Now, S is a necessary condition for T. Now, is that S implies T? T implies S, or it doesn't matter? It matters. T implies S. Okay, so if you put S implies T, that's a -8 because you cannot recover from that. The disjunction of U and Q. What does disjunction mean? Or. See? I told you that thing worked. The negation of the conjunction of R and not B. Did you write that? Not S, if and only if Q. U is a sufficient condition for not B. Is that U implies not B, or is it not B implies U?
you
implies not.
How do you know?
like
Because the F's are pointing that way. See, you guys learn. Just like for the necessary condition, it's because the Y points the other way, right?
Yeah.
See, you guys laughed and then now it works. Now, based on these, what can I conclude? So what we want to do is change all of these to conditional statements so we can use the law of syllogism. How do I change an or statement to conditional?
Negate the
Negate the first, leave the second one alone. Now, what about this thing here? Can I distribute the negation sign?
Yes.
Yeah, so not R or P. But then can I change that to conditional? Negate the first, leave the second one alone. Okay, now this one, biconditional, you can use in either direction, so we're gonna use it in whichever one is gonna help us, so we don't know yet. So, what do I start with here? Because this is not necessarily in order.
T or R.
Should I start with T?
Sure.
Yeah, or should I start with R?
I didn't know until today when my friend told me where to start. I was like, oh.
Do you guys understand where to start now?
Is it because they're alone like this?
What do you mean alone?
Yes.
Because look, A implies B, B implies C, C implies D, D implies E, therefore what? A implies E. How did I know to start with A then? Because look, this one goes with that, this one goes with that, this one goes with that. See, there's only one A and one E, so either you're going to start with A or E. So in this one, you're either going to start with T or R, right? Okay, so which one? You guys make up your mind?
T.
Okay, so T. T implies S. Now, if I'm going to use the law of syllogism, the next one has to be S implies something. How can I get that? So should I use it not S implies Q, or should I use this as Q implies not S? Which direction is going to be more useful to us?
Not S.
Q implies not S. You know why? What's the contrapositive of that? S implies not Q.
Oh, okay.
You get it?
So the biconditional can be like turned into like conditionals then. Because I was like,
Yeah, you can
I
use
was
it.
stuck. I was like,
No, we did that yesterday, right?
What? Oh.
That was on the homework, right? The moon is full if and only if something. The goblins are out or something.
Yeah.
Remember that?
So
A
you-
biconditional means you can use this in
Either one.
either direction. Pick the
Okay.
one that's gonna work for you. So then in the next step, I need not Q implies something. Where can I get that? The contrapositive of this. Oh, so Mr. Park, contrapositive is pretty important. Yeah. And then I need now U implies something. Where can I get that? Right down yonder. And then now I need not P implies something. Where can I get that? The contrapositive of this. Not P implies not I. So, if gorilla implies banana, banana implies armadillo, armadillo implies aardvark, aardvark implies bat, bat implies cheetah, then what can I conclude? Gorilla implies cheetah. Woo! How many people got that as their answer? Okay, that's -3. But I did everything correct, Mr. Park! No, you didn't.
Oh, this
Because look at the direction. It says what disjunction
Oh, it's
can
fine.
be determined. Is this a disjunction? No, it's a conditional statement. So a disjunction is an or statement. So how do I change a conditional to or?
First,
Negate the first, leave the second one alone. If you write that, that's full credit. -0. Oh, so Mr. Park, we should read the directions. Duh. What if you wanted to be fancy? Mr. Park, I'm gonna show you I know stuff. I'm gonna factor out the negative sign, the negation sign. What if you did that?
not disjunction.
Yeah, this is the answer. Don't do this and don't do that. Oh, let me tell you what some person did last year. I can't remember the name, but you know, instead of making, this is the negation sign, right? Somebody actually did this. Statements cannot be negative. Numbers are negative. Statements are negated. There's a difference now. Do not make up your own symbols. That's when bad things happen.
There's a slice of
I think it's coming to me. Tran.
Oh, what?
Well, I don't want to mention any names. And then finally, number 7. Design a network. Now, I am not going to grade on efficiency. As long as yours works, you're going to get full credit.
And you said, you bet that people take this wrong, right?
I know, because every year people have trouble with this. So you have to design a network so that the output is, now P is true, true, false, false, true, false, true, false. What do I want in this one?
0, 1.
False, true, true, false. Okay, so this is how you should take. Do I know of any statement that's false, true, true, false, or the negation of that? True, false, false, true?
Maybe.
No.
Yeah, what do you mean no?
Biconditional.
The biconditional. So this is what actually I gave this problem like 20 years ago. You know, one student had the gall to do
What's
this.
the name?
They go like this, okay, P and Q. Now there's only two. There's
Oh,
only
they're making
two
the circuit,
inputs.
yeah.
You know what they did? They go like this. Oh, if it only did,
Yeah.
and then negate it. Oh, that's easy to grade, -8.
Oh.
No, you only have and, or, and not.
Oh,
You only have and, or, and not.
-8.
You have to, wait, I mean, yeah. You have to build this, you're the engineer, you have to design a network that produces this. That's what you have to do. You cannot just make up, you gotta pay somebody to make it.
Or Q.
Okay, so, how do I do it, Mr. Park? Well,
And it.
so this is what we want, not
Yeah.
P if and only if Q, right? Isn't that what we want?
Yeah.
Okay.
What the heck?
Because it gets true, false, true, true.
Is there a way I can change that to just ands, ors, and nots?
Yes.
True, false,
Yeah.
true.
Okay, what is the biconditional? We did it on our homework. What does this mean? P implies Q and Q implies P. Yeah, but that's still not and or. Well, can I change a conditional to an or?
Maybe.
Negate the first, leave the second one alone. And then what about that? Negate the first, leave the second one alone. Now it's all ands and ors and nots. So all you gotta do is draw a picture for that. Or do you want to distribute the negation? Because if I'm grading for efficiency, then right. So if I distribute this negation sign, what are you gonna get? What is the negation of this?
P and not Q.
P and not Q, and then the and changes to or, and then what is the negation of this? Q and not P. Now, if you want to, you can just draw the picture for this, or if you want to, you can just, I don't care, as long as it works, you're gonna get full credit. Some of you, did somebody come up with something different that worked? Okay, it doesn't matter, as long as it works. Okay, so how do I do this? So P gets ANDed with not Q, so Q gets negated, and then it gets ANDed with P, and then it gets ORed with Q and not P. Now, you can't, every year there's always students drawing another P and Q. No, there's only 2 inputs, it's like you're plugging it in.
Oh.
You know, you plug it in. So, what you gotta do is, what are we doing? Q, so here's Q, and then that gets ANDed with not P. So, P, jump over the wire,
Oh.
not P. Yeah, don't make up your own.
Oh yeah, jump over the wire.
It's ANDed, and then these 2 get ORed. Boom! Full credit, baby. See, and look, there's only 1, 2, 3, 4, 5 symbols. very efficient. Whereas if you did this one, it would have more. There would be 6 symbols. So if you're gonna hire somebody, you're gonna hire the one that had the fewest symbols, right? Because it costs money. Now tomorrow, what if you cannot remember that this is and, this is or, and this is not? What could you do that I might accept?
It's right in.
Just make up your own shape.
That is that or.
And then
Like,
marry
okay,
key.
what if you cannot remember this is and this is or? What if you cannot?
Break the word.
No, yeah, so make a box and go
Yeah.
and then make a box here, or, and then I'll just take off 3.
Ah.
1, 2, 3. No, that's not a fatal error.
Best of-
That's part of it to learn the thing. These are electrical engineering symbols. You can make up your own. Like if you go to any country, name a country.
Bangkok.
And that.
Thailand, they have the same symbols. All right. So now we are ready. So don't you feel ready for the test?
No.
No, I feel ready.
I haven't seen part of that, so yeah, I'm fine.
Okay. Unfortunately, we only have 15 minutes, but good thing today's lesson is pretty easy.
This is hard.
We are going to linquad. This is the next chapter. And like I told you, just because you get a super high score on this test doesn't mean that you're top mathematically. I'm trying to turn you into a top mathematician. Because now, this is what the course is going to be like. You got to think, you got to be good at arithmetic and algebra. I got to increase your skills, otherwise it's very difficult to succeed in calculus. Okay, now what the heck does linquad stand for? What is that?
Quadratic.
Linear and quadratic functions. Now, to the first lesson today, you don't even have to write equations of lines yet. We're going to do lines and then parabolas. All you have to know are the basic formulas. So, let's go over that. In the Cartesian plane, you guys know what the Cartesian plane is?
That thing.
Yeah, that thing here. Why do we call this the Cartesian plane? Because in honor of the mathematician,
Cart.
who?
Descartes.
No, Descartes.
Descartes.
René Descartes. Did you guys take European history? What grade did you take European history?
The fisher in the one.
8th grade? What do you guys do? Have you ever heard of the French
Oh, I think.
mathematician and philosopher,
Ninth grade.
René Descartes? He was one of the fathers of analytical geometry. So that's why it's named after him. René Descartes, Cartesian plane. Okay, let's go over basics. If you know 2 points in the Cartesian plane, x1, y1, you don't have to take notes because this is all in the notes. How do I find the slope between those 2 points? Come on, this is algebra 1. y2 minus y1 all over x2 minus x1. That's how you compute slope. And can I assume everybody knows the basics about slopes? Okay, like for example, if I said I'm thinking of a line that has a slope of 1/2, you should have an idea of what it kind of looks like, right? What about a line that has a slope of 3? What about a line that has a slope of like -1/3? Yeah. What about -4? Bam. What kind of slope does a horizontal line have?
0.
Vertical?
Undefined.
Fine. And then how do you tell if 2 lines are parallel?
Same
They have the same slope. How do you tell if 2 lines are perpendicular?
Opposite reciprocals.
Negative reciprocal. So yes, those are the basics about slope. Another formula you're going to learn is how do you find the distance between 2 points in the Cartesian plane? You use the distance formula. x1 minus x2 squared plus y1 minus y2 squared. These are all formulas you got to know for the SAT as well, right?
Yeah.
And then, how do you find the coordinates of a point that's halfway between these 2 points? It's called the midpoint formula.
Y1.
Come on, SAT prep, we did this.
2/2.
Take the average of the x's, take the average of the y's. There you go. That's what you need to know on tonight's homework. You just gotta know these 3 things. It's so easy, it's ridiculous, unless it's not. So let's say I have a quadrilateral. Okay, what time do you have? Okay, give me a point, and don't say 0, 0. 1, 1.
3, 4.
Okay, that's at least a little creative.
Nice.
Here is a point 3, 4. Okay, I gotta think now. Eh. So what did I just say? 7, negative 1. Okay, and then what did I say? What did I just say? 1, 0. And then something's wrong here. I'm not thinking clearly. What did I just say?
Oh my god.
No, I'm trying to come up with a problem that's why, but it's not working. Wait. Oh.
5, negative 8.
Negative 8,
Negative 5.
5. Is that right? Am I doing this correctly?
That's it.
Okay, whatever. We're just gonna go with it.
Repair 'em.
Okay, now this is just a sketch now. This is not the problem. Okay, using only the distance formula, determine what kind of quadrilateral this is.
Trapezoid.
A, B, C, D. So you can only use the distance formula, determine what kind of quadrilateral this is. Because what are the choices? It could be a rectangle, could be a parallelogram, could be a square, could be a trapezoid, right? So using only the distance formula, okay, what's the first thing I should do? We're using the distance formula, that means we want to compute a distance.
Opposite distance.
Okay, how about AB? Let's start with AB. How can I compute this distance? Use the distance formula. Now, in this class, like when you took pre-algebra, algebra 1, algebra 2, your teacher wants you to show all the work, right?
Yep.
The less work you show, the better. I would like it if you just looked at it and you go, 2 root 5. I would like it if you could do that. No, because you know what? This is what, go square root of x minus x squared plus y minus y squared. That's the square root of negative 2 squared plus negative 4 squared. And that's the 4 plus 16. That's the square root of 20. And that's 2 root 5. I don't want that. I want boom. No, I'm serious. The more you can do and you get, the better for you. I don't want to see all this. I mean, if you want to write it, you can. But I'm not going to look at that. I'm just looking. See, because if you don't get this, then it's kind of almost fatal. Okay, now BC. Let's see if you guys can do this. BC. So here, let me show you how. I'll show you how I do it in my head. Okay, what's the difference of the x's? 4. What's the difference of the y's? 8. Square each of them. 4 squared is
16.
8 squared is
64.
add them together. 80. What is root 80?
4 square root 5.
4 root 5. Boom. Can or cannot?
Sure, maybe.
Okay, well, if you practice, you probably could. Okay, let's do CD now. CD. Who's got this? 2. What's the difference? 2 and 4. Square both of them.
4.
4 and 16. Add up
20.
together.
T squared root
So
5.
2 root 5. And then finally, AD. What's the differences? We got 4 and 8.
4 root 5.
Okay, 4 root 5.
I just did.
So, what did we just figure out? This side equals this side equals that side, therefore what can we conclude? No, it's a parallelogram. How do we know that's a right angle right there? We know. So all we can conclude right now, it's a parallelogram because the opposite sides are equal. Remember your geometry? Anyway, you know what kind of mathematics we're doing now? We're doing mathematics called analytic geometry.
Remedial.
Analytic geometry. That's doing geometry problems using algebra. It's the melding of algebra and geometry. So, using only the distance formula, because this thing might be a rectangle, what could I look at? That might help me. No, you cannot use slope. You can only use the distance formula.
Diagonal.
The diagonals. Now, if this were a rectangle, what can you say about the diagonals?
Equal.
They have to be equal. So, if the diagonals come out equal, it's a rectangle. If they don't come out equal, it's just a parallelogram. So let's do this. AC. Who's got this? Iwakiri, redeem yourself. AC. Do like what I was telling you. Difference of the x's.
42.
Okay.
No. Difference of the x's.
Oh, that one. Wait.
AC. A and C. Difference of the x's rhymes with move.
2.
Okay. Difference of the y's.
12.
Okay, so square both of them.
Yeah. And then 2. 2.
You don't even have to simplify, just give me the number.
Oh, 148.
Okay, good enough. Now, do I need to simplify that to 2 root 37?
Yeah.
That's good enough. Okay, what about BD? Who's got BD here? Difference of the x's. 6. Difference of the y's. 4. Square both of them. 6 and 4. If you have to write it out, 6 and 4 is 36 and 16. What is that?
52.
Root 52. Is this a rectangle?
No.
No, it's not. So the answer is a parallelogram. Okay, we only got 6 minutes left. Now tonight's homework, you get to use your graphing calculator. You guys have it?
Yeah.
Okay, now, right now, the only thing you guys know how to do with your graphing calculator is add, subtract, and play games, right?
Yeah.
Let's turn it on.
Okay, so let's do this. In fact, just for the sake of simplicity, why don't we use the origin? 0, 0. Give me a number over here. Give me some coordinates. 9, 1 then. And then give me a coordinate over here somewhere. Quick. 4,
6.
Oh.
6. Okay, let's put 7. These 3 points form a triangle. Using Heron's formula, because that's tonight's homework. Using Heron's, first of all, before we even go on, do you guys remember Heron's formula?
Yes.
Are you hero?
It is.
Heron of Alexandria.
K.
Very good. You guys are remembering something. The area, it's not K though, it's kappa. It's a Greek letter kappa. Usually we use that for area. Kappa equal the square root of
S. S minus A.
Oh, that one.
Mr. Park, I
It's
don't
all
know.
up here.
Wait,
It's
wait,
all
wait.
up here.
Hey, try looking in the notes, it might be there.
Google.
Yeah, but Mr. Park, what's S? What's S?
A
Sine.
plus B
The
plus C.
semi-perimeter.
After. Right?
Okay, so I'm going to let you use your graphic calculator to use Heron's formula to calculate the area of this triangle. We've got 4 minutes to do it. So, in order to use Heron's formula, we need to know the 3 sides of the triangle. That's A, B, and C. So how do I compute the length of this side right here? We just did it in the previous problem. You used the distance formula. Okay, can we do this? Let's do this as quickly as we
Square root
can.
of 82.
Square root of 82. Okay, what about this one? It's 5 and 6. Look, 5 and 6. Square both of them. 25 and 36. Okay, root 61. Okay, what about this side? We got 4 and 7.
65. Square root of 65.
Mr. Park, these numbers are so ugly, the answer's gonna come out so ugly. Well, that's why I didn't use a graphic calculator. Actually, the answer's not gonna be ugly, it's gonna be nice. You know how I know?
No.
No, it doesn't matter, it's gonna come out nice. It has to come out nice. Just think about it. Okay, were you in my summer school class?
Yeah.
No.
When we had this problem in summer school, how did we find the area of this triangle? What did we do in summer school?
Draw a box.
Remember, we put the box around it?
Oh, we did?
Yeah.
So, how do you find the area of this
yeah,
triangle?
it has
You
to
find
be
the area of the
nice.
box, and you subtract these 3 right triangles, therefore it has to be pretty nice. The answer is either gonna be an integer or something 0.5. It has to be.
How can we
Just think about it.
store information?
Okay, but I want you to practice using your graphing calculator. Okay, so, what's the first thing you need to do? You need to figure out the semi-perimeter. So, the semi-perimeter is the square root of 82 plus the square root of 61 plus the square root of 65 all over 2. Now, do you guys know how to use your memory on the calculator?
I forgot.
No.
Okay, and that's why I'm going to show you.
Oh, is this that
God.
stop? So
This is so confusing.
Okay, here's your calculator. You want to be in run matrix mode.
What is that?
Okay, now watch. This is where you do all your computations. So watch what I'm going to do. Square root of, what's the first one?
82.
82.
Ooh.
Get out of it. Oh, I forgot the parentheses. Let's get it there. 8 plus, what's the next one?
Square root of 61.
Square root of 61.
Oh, handy.
Get out of it. Plus the square root of 65. Get out of it. Enter. Then I gotta divide that by 2. This is the semi-perimeter. Now watch what I'm gonna do. I'm gonna take this number and I'm gonna store it.
Mm-hmm.
You see this button right here, the right arrow?
Mm-hmm.
I'm gonna take this number and I'm gonna store it. Now, this calculator has 26 memories. You can
Whoa.
pick any letter from A through Z. So which one do you think I'm gonna pick?
See S.
S. So alpha, you see alpha?
Yeah.
Alpha S. Boom. That number is, with all its decimal places, is now stored in S. So anytime I punch in S,
Sick.
it's gonna plug in that number. Now what do you think I'm gonna do? I'm going to
Square
take
root.
the square root of 82. And what do you think I'm gonna do? I'm gonna store that in
Answer.
alpha A. Then I'm gonna take the square root, where's the square? Gosh, I can't see. What's the next number? 61. I'm going to store that in alpha B. You guys see what I'm doing?
Whoa, that's hard.
And then now I'm going to take the square root of 65. I'm going to store that in alpha C. So I got all the numbers, they're stored. So all I have to do now is punch in Heron's formula. So watch. Oh, boo! Square root of alpha S. Where's the S? Times. You guys know what I'm talking about here? So all you have to do is punch in all the variables, and the calculator is going to crunch all the numbers and just spit out the answer. Isn't that a lot better than taking this and put it there?
How long have you looked at that?
All right, we'll see you tomorrow. I don't see you tomorrow. I'll see you on. Wait, Thursday's the test.
Yeah, I know.
Okay, if you have any last minute questions, I'm always here 6:30 in the morning. Because if you try to ask me a question right before the test, I'm not going to answer.
Thank you.
Okay? All right.